Just talk a little bit about emerging technology. And first of all, this is exactly what IT is doing today for our citizens. We have some numbers here. 600, almost 500,000, more than 500,000 of the citizens, city users' IDs. We serve 17,000 our employees' devices, and all the 3,000 city vehicles, everything, these are all connected through IT. And we're here to provide services. And that's basically our North Star, to provide our services from IT, right? And always this fancy word about emerging technologies. So I'd like to basically define what exactly are emerging technology here. Can basically see AI, some of the AR, VR you have seen here, this tech center here, blockchain, and lots of these robotics stuff here. The reason I want to show this is basically for each of these technologies, we treat them a little bit differently, because each technology has their life cycle and their maturity. So we cannot invest our limited resources in each technology equally. So our strategy is looking at, for example, that's why we have this beautiful tech center here, to see what technology we can bring in at what point, and what kind of resources we should invest, and what kind of engagement we are with this type of technology, right? For example, it's quantum, with some of the blockchain. Basically, we're doing work with university, work with pilot stage here, and understand a bit more before we even jump in. But for AI, we know that although it's a hype, but AI, we does already see some of the return, some of the tangible use cases come in. So our focus will be a little bit different with blockchain and say quantum, right? Because that's how we treat things a little bit differently with different type of technology. So in the City of Calgary here, basically work with Monique's team and our other IT teams. What we're doing here is based on different technology, and also we have a little bit of process, say from testing the technologies, pilot technology, to basically bring it to our enterprise setup, to eventually put it into production. That's a life cycle as well. It's different phases, right? From getting the concept, understand it, and basically test it out here at the lab, understand the feasibility, then to the other team that are looking and say, hey, how can we bring the technology under the City of Calgary's cybersecurity framework, our technology framework, and then eventually roll out. And also, most importantly, is also understand, make sure that we can transfer the technology into our internal IT team and internal business unit teams. Understand that it's not just a technology outside. It's something that we can embed into our daily workspace. So it's actually a long process from here, this lab starting, to somebody use it at the field. Sorry? Oh, thanks a lot. Yeah. That's why I have these great people here at WAVE, right? And I always love to see this I call iceberg model. Use AI as an example. And this is not to be just for AI. From enterprise emerging technology stack, this is what we always see. The beautiful part is always above the surface is the application side. Let's say we have AI applications, pothole detection, or whatever. That's visible. And that's what most people see. But under the surface, typical is the AI models, right? And in the past, AI model is typical, is relatively difficult to build. You need data scientists. You need lots of expertise to build models, but that's no longer the case, right? Low-code, no-code models, open source, and lots of models. Things to understand, lots of these large language models are really available. So the tricky part right now for enterprise IT to do this type of work is focused on how we can identify the right data from our enterprise, and how can we bring this data together? Where do we store it? So I know that our Dave Bigers, another IT manager here, is going to talk about the enterprise data strategy this afternoon. And that's a key component that without take this data piece out, this is going to collapse, right? And then the bottom line here, we have the enterprise infrastructures. So here we are in Azure shop, right? So in our Azure environment or other cloud environment, also potential could be city data center or could be a partner data center here in local. So that built our infrastructures. And I kind of draw a couple lines here. You can see security is something that always ties these pieces together from different different layers. I would say legal and privacy. Legal, typically, we talk about those application layer. For example, if we roll out a chatbot facing external, citizen facing, basically we need to do lots of research from a legal and legislation perspective, right? And then privacy and access touch the enterprise data level and also the models, right? The transparency of the models, what kind of data we're using. When we put all these data together, would that create some privacy concern, right? So that's what we always look at, say, bring in a model to the city. It's different with doing a consumer or individual development. At home, I do this all the time, right? Download a model, put it on a machine, I get my AI done. I'm teaching my daughter doing that as well. But at the same time here, the city, enterprise things are completely different, right? If any questions, feel free to raise hand. We do have, I think we have 10, 15 minutes at the end for discussion as well, right? So first of all, I would like to share a bit about our, we talk about IoT. And here our focus is industrial IoT, right? We call IIoT. And I want to highlight a little bit about our LoRaWAN network, the long-range low-power network. So I'm not sure how many of you are familiar with LoRaWAN network. Raise hand. Excellent. Oh, I feel that I'm in the right place here today. Thank you. These are basically the network that are able to support battery power sensors. And you might ask, why do we need battery power? And that's because we might not necessarily be able to find fixed power everywhere, especially large cities, right? So the battery power sensors last years of operations actually give us advantage that we can deploy sensors in almost wherever we want. And last years, we don't have to replace them. So that gives us an advantage, say, hey, let's use these solutions and collect all the data for us for future data, machine learning, et cetera. So City has a city-wide covered LoRaWAN network, which is basically, I'm going to talk a little bit about, not just for our internal business users, also open to our local communities, startup companies, researchers through our Living Lab programs. So that's basically the LoRaWAN network that right now we're sitting here. If you have a LoRaWAN devices, you should be able to see or able to connect to our network through of course, some approval process going on, right? So the coverage is quite big for the city-wise. That's our LoRaWAN network I want to mention. Some of the use cases I want to highlight here is that, for example, this is the use case for urban heat. So every summer, in certain hot spots across the downtown areas, there's urban heat problems. We could basically understand these problems through satellites, but those are the resolution-wise and the update frequency is not as good as you put a sensor right at the spot there, right? So that's why I deployed some of the LoRaWAN urban heat sensors with our business partner, I think with our climate team, to understand each spot, say, what caused these urban heats model, these islands, and what can we do to might be able to change some of these, say, can we plant more trees? Can we build more buildings? Is the shadows help, or does the trees or whatever the structure is going to help, right? And potentially, if we can merge this with some of the cool AR, VR setup here with Chase, right? Then we'll probably understand that, hey, how does this heat model demonstrate in a 3D way? How does it look like, plus sound, everything? So the conversion of IoT, AR, VR, definitely going to give us a little bit more head, say, hey, now I understand better about our environment and ambient, right? So these are the studies that, thanks to our business partner from the environmental team, they've done a really good job and kind of see the value of putting these sensors there, right? I would love to see this and see I think Colin is our lead engineer for IoT. He done lots of these work. And you see the reason why we want to monitor, say, when and how we should collect our garbage. Instead of we say, hey, we send everybody at AM there, collect everything. Now I think some of the city parks sends garbage bin. If you open it, you can basically come and see that there's potentially a sensor actually embedded on the cover and the lid there. And that sensor is a time of flight sensor, understand that how full the garbage bin is. 70%, 80%, send an alert to our team, parks team, and then they basically get dispatched to collect the garbage out of the garbage bins, right? And that's a great use of say, yeah, you don't need to connect a power to the garbage bin. Deploy a sensor there and engineer it properly and make sure that you have those reporting and alerts sent out to our operation team. And IoT to us is always IT plus OT, right? IT cannot do all the work. It's all operation technology in the field that basically help us leverage the benefits. And this is the latest one that I think our team done for also parts trees, understand the soil, like the soil moisture. So embedded in some of the trees, and also you can see the reason I want to show this the other picture is that putting something on the fields also need to understand how we can protect these assets, right? So properly protect these sensors under this covered and make sure that it's tamper-proof, right? So yeah, these are the tree monitoring sensors as well, and you send some signal telling us that like does it get enough water for these trees, right? And outside, like even across the street here, a few of our manhole water levels, actually there's our lower end sensor there. And you might ask like, why do we want to monitor this water level? I'm not sure you remember time to time, these water level coming up, it's potentially impact our C-train services. Because there is basically high voltage equipments embedded in this manhole. And the water level basically going to put some of the hazard to our equipments, right? That's caused some of the public transportation interruptions. So the challenge here from engineering perspective is that because you can see it's deep and underground, and also there is a metal cover. So wireless signals always have the difficulty penetrate all these things, right? And that's what you can see on the right-hand side here. I think the team cleverly designed a repeater, that little white device is out there. As a repeater, collect the signals from underground and then relay it out, right? And that's how the design being worked. And these are the things that require sort of the team here to understand the technology outside, but there's a bit customization that we need to make it happen within our soil. Things are different. There's nothing out of the box can work just beautifully here, right? We all know that. It has to do lots of the engineering pieces here. And the team recently also deployed some sensor for monitoring climate, right? You can see humidity and weather stations. And I will be interested to see our dashboard, like what does it tell me today with the snows and everything, right? And also some solar radiation sensor. I hope this one actually tells us about the northern lights, but I haven't checked with Colin, so maybe this one will give us a little bit of indication about northern lights alert. So this actually gives us lots of data collection points. Right now, the previous setup is that city probably has, or with federal or provincial, we probably have some weather stations at certain spots only. But now this gives us a lot more granularity. Say, hey, how's around the downtown work, the micro weather? How's the northwest different with downtown or with southwest? It gives us a lot more indications, right? And potentially we have been talking about either working with UFC or in our community center to roll out more sensor into our community center and understand and helping our city community members understand that how is their micro weathers impact them, right? Wind, air qualities, stuff. So that's upcoming. And you probably saw the news, the CBC, etc. talk about, yes, the traffic noise monitoring. That's also coming from this team, the IT team. That basically we're working with our bylaw officers, and they basically provide them a tool to understand how is the traffic monitor, how does the traffic heat map look like, right? The last one to mention that also there's a merge of AI into these sensors. So we're working with the UFC to say, hey, can we basically just using AI on the edge to classify the sound right at the spot? So instead we have to send all these ambient signals back to the cloud or our data center to process AI. Let's do it at a spot. That prevents, first of all, we get much quicker reactions or much quicker actions. Secondly, we don't need to worry too much about sending some sensitive data over through the, right? Just process it and then destroy it. What we need to know is that, is this really a traffic noise or something else? That's the only information we need from the edge. And that's the beauty about these edge AI, IoT we're looking at right now, right? And the same thing applies to camera as well. I think that Colin and our AI teams are actively working on say how we can put AI into some of our camera, right? And that basically helping us preserve a lot more privacy. Say we don't necessarily have to capture all the images from the streets back to our cloud, right? And our team also, like here in IT, we also deploy the RPA tool for internally the process to automate lots of our human or mundane process. So just basically a quick snapshot here that today we have about 40, I think this number is a little bit outdated. We probably have about 50-ish of different, we call RPA bots across different business units to helping them automate the process here, right? And what we always believe is that take care of what is important and automate, let the machine and algorithm automate the rest, right? So free up some of the time so our employees can focus on something that they're more interesting, right? I want to cover a little bit about AI machine learning. So what I'm showing you here is the AI machine, the deep learning model that we use based on our existing security camera to find out how many people actually were during the Canada Day event. This is actually, I think it's around midnight, 10:30-ish, during a Canada Day when people gather and try to see fireworks. And you see these red dots actually is the algorithms point out these are the human objects and then give us the counts, right? So the reason we want to do this is basically helping us do a proper understanding about better planning of event planning and capacity planning, also from public safety perspective. Right now we understand that, okay, how is this space enough for us to hold this type of event? And this is the AI model results that we use for our payment detections. With good images, you can basically see that the machine learning model actually able to detect and identify different type of defects better than human eyes. You can see some of these red boxes are the prediction results. And so these are actually capture some of the easy missed targets by human eyes, right? And until we actually work in this project, we didn't know that there's actually 10 or probably 12 different type road surface defects that we need to identify, right? So it's actually quite engineering practice. So it also proved that using AI machine learning, given its good quality of images, it actually predict and identify these different defects very well, right? Pothole actually turned out to be the easiest one. And there's other type of defects that are relatively difficult. So the prediction accuracies depends on the samples of the defects we have. Right now, pothole is so far is the easiest one to identify. We also use AI machine learning to helping our fleet's asset team. So City has 3,000-ish vehicles. So we use AI machine learning to help predict, in this case, specifically say, in 2 weeks, which waste recycling truck's going to break down. And if it's break down, what's the probability of that truck's specific truck, say number 1, 2, 3, 4, 5, is going to break down? And if it break down, what's the root cause? Is it because of the arm, mechanical failure, or what else, right? That's a really interesting study. And make it more interesting is that this result is not like 90% accuracy or 100% accuracy. This is actually only 60-ish% accuracy. And you might say, yeah, that's not good. But it turns out what we also found out is that above 63%, if I remember correctly, business-wise, we break even already. When they say break even, that means if you trust this model, just recall that the vehicles come back to do a preventive maintenance, rather than wait until it breaks. City actually save more money than just let it wait and let it break down and create more problems. So that's a very interesting finding from an engineering IT perspective. We never thought about that. We said, oh, I need to get 99.99%, right? That's not the case. That's a really interesting case that in kind of helping us that, okay, yeah, you would bring technology. Let's work with our business unit and understand that what exactly is the benefit. Do we really need to achieve that higher accuracy? You might not be. You might not be able to, right? So that's a really interesting use case, and thanks to our fleet team that actually give us the, like, work together and get some of these insights out. And very similar, this is for our facility management. They're the team that basically helped build this beautiful center here. So they manage about more than 100 city, I think 150-ish city buildings, right? I don't have the right number, but. So we use AI and machine learning model to help them classify say what work models, what work orders are actually predictive maintenance versus more these repair, or they call corrective maintenance. And then from each corrective maintenance, identify what kind of root cause is it? Is it because the door is broken, is the lighting is not working, etc. Right? So these are all machine learning models working on behind for them now. And we also, I want to show these cases because this is how we use multiple layer of classification, helping our supply management team to understand that for each single city procurement, which buckets it should go into. So different for example, if I purchase an iPhone, it basically goes to IT, the first layer. Second layer could be like wireless devices. Third layer is actually iPhones, right? And to that granularity is helping us understand that, okay, maybe based on that bucket, how can I budget my next year's fundings? And how do I basically calculate that based on the inflation on different categories of the devices or what we're going to purchase, right? And so this is actually right now using machine learning model now to doing this. We also use basically our OpenAI models, right, in Azure, to when citizens submit an access code, we use OpenAI on the back end to validate the information, right? Instead of humans, say validate, okay, Jonathan's 123 streets. So these are very simple use case, but it's very powerful. Instead of human has to validate all these inputs, the AI actually tools validate right away on the back end. Oh. And we talk about generative AI, we have to talk about chatbots, right? So we do have a few chatbots working, but right now we all contain internally. Because we want to do a thorough testing, make sure that these AI chatbots perform what exactly we need. Here's a few examples that how these AI chatbots work, right? A quick example could be Power BI chatbot for technical support, provide technical questions for Power BI licensing, technical issues, right? And also internal testing with our planning and development team for building code by law, some of these Q&A for internal training, internal testing as well. And we are building a pilot chatbot with our CSSC team to see how we can, this could be potentially going external on Calgary.ca, helping us understand, helping answer questions about low-income questions. Say, hey, if I'm a low-income, that categories, what kind of city services I can access, right? So these are AI chatbot that city's been developing. We also use, city has tons of assets, right? So instead of basically say, yeah, human take a pictures and take it down, understand, put it into spreadsheets, say, yeah, this is, for example, this is a water pump, what's the manufacturer, and type everything. So right now, the model that, the solution we use is that take a picture, and then AI capture everything, and then just dump all the details in the database for us and for our asset management team, right? So this is make the consistency going on and automate lots of these process. Although this sounds pretty easy, but this is really extremely difficult because you can imagine quality of images, different type of assets. Is it different type of the catalogs that are available by different manufacturers? How could you make sure they have a consistent metadata, right? So actually there are lots of things happening. Remember that iceberg pieces? That's exactly happening on the back end. I also want to mention a little bit about robots, because to us, we understand that AI should not be just large language models. Eventually, it's already getting into robots, right? And so, for example, for today, if we have robots, we can clear our path with, like for snow plowing, for snow clearing. And basically, this is how the city service is going to move forward into. So with that, basically, we're working with U of C to build our Make in Calgary robot. Instead of purchasing a robot, actually this from inside the models and even the exterior design. And what you're seeing here is the core of that we call YYC robot. And this robot basically going to be doing, hopefully can put it in the City Hall once it tests successfully. We'll come here first and then go to City Hall and then basically able to do a little bit more customer services and interaction with our citizens to provide citizen services. So with that, I also want to basically summarize a little bit about what we learned. I always call AI here is always innovating. That's our definition of AI as well. And here's some of the things we learned is that we need to innovate with the strategy, right? So we do have an AI strategy. We actually published an AI strategy for enterprise internally first. And now, actually, sorry, we haven't published it. We actually get approval from ELT and all the leadership team. Our AI strategy actually helping us set up our enterprise AI governance model, define our technology platform, risk management, and also have dependency on our enterprise data strategy as well. And we also cover about how do we communicate AI in corporate-wise, right? Make sure we have a consistent message. So under this strategy, actually, there's an AI working group that helping with legals, cybersecurity team, privacy team, and IT help govern lots of these in tech and provide directions. And here's our AI from City of Calgary perspective. These are our AI guiding principles, right? The thing I want to mention is basically there's accountable to people. That's always our people first guidance is that we deploy AI, we use AI. It's not because AI is cool. We need to really understand, able to measure and explain what's the benefit of using AI. That applies to other emerging technology as well, right? And we also define AI as a corporate technology. And that's why right now the AI governance, the AI steering committee is actually under the we call CTC, the Corporate Technology Committee as well, as a subcommittee, right? And the other thing we learn is that innovate with a purpose. That's what I say. Innovate not because it's cool or fancy. In the case I'm showing here is the one that I think a couple of years the team worked with transit to help putting a radar. This is actually a 24 gigahertz radar up there to help prevent or monitor, detect the copper theft. Because I'm not sure you're aware of, actually there are lots of copper theft. They just cut those 2 meters of copper. Those are actually high voltage return. And then they sell these coppers for probably $200. But that creates lots of issues. It's gonna disrupt all the trains and basically create also safety hazard as well, right? So the purpose is that now we can have a mechanism to help detect and send an alert to our officers, transit officers, to say there's something going on out there. And you might ask, why don't you put a camera? It's because it's difficult to connect all the wires, everything to the middle of the train track. That's why some of these lower-end technologies becomes useful. You just drop a radar there, and the radar also give you a chance that basically say, yeah, you don't have to worry too much about the privacy pieces, right? This is just radar. It doesn't say anything, just reflect, right? I always press the wrong button about moving forward. Yeah. I want to say also innovate with an impact. When we talk about impact, this one talk about volume. This one I show is also with our transit teams. We have lots of buses, so every day there's hundreds of these maintenance records need to put into a system to understand and trigger the maintenance. So this is one of the, using our RPA bot, scanning all these documents, put into a system right away and consolidate together. So this one is extremely simple, but the impact is that it reduces hundreds of data entry every day. So the impact piece is on the volume, right? And what I'm showing here is the innovate iterations. This is the third design already, right? The third design for our for transit team when they do they call the way stack. Not sure some of you understand that the way stack is when you have a train, there's a waste stack is basically, there's a power cable above the trains. And basically the power cable tension need to be maintained to a certain level so that it can make sure there's the distance or the contact with this vehicle can provide the power supply to this vehicle. So any tension changes to this power could create a problem. Let's say wind, temperature, these tension cable could drop. That could create lots of public safety and operation issues, right? So how to monitor accuracy of these tension cable is a really tricky problems. You can't just find a solution and say, hey, could you somebody come here and do it, right? So this is already the third generation engineering design to put it there, using this way basically it's detecting a displacement sensor, understand it's a wheel actually, understand that how much of this displacement happened through this wire, and then convert that analog into digital, into a voltage change, and then send it through our LoRaWAN network back. Say, hey, there's something changed. You might want to take a look at that, right? So it's pretty interesting and cool design that we put out there. And this is the back end, kind of understand that, okay, at what time, what's temperature, what's the waste stack changes. Also, I want to say that innovate with the vision too. And when I say vision, this is exactly from the pavement project. When you say the AI for pothole detection, which basically trigger another innovation is that, hey, how about we put a city camera on some of the city vehicles? Because city vehicles travel all the time to certain routes, fixed routes almost every day, every week. Should we create our own Google map or Google view? And that's exactly what we're doing now with the mobility team. These camera, 360-degree camera, was put on city vehicles. And you drive around and capture all the images and actually contribute to Google Street as well. So right now, you go to our Google Streets. Actually, City of Calgary has lots of our street data there and updates very frequently. And the beauty about this is now imagine that we have all these data. It's not just detecting pothole. We can detect, or maybe detect that maybe traffic light is gone, a stop sign is gone, or a tree was cut, right? So lots of these becomes that, okay, these are great data that now we have to able to give us lots of insights. And the last one I want to show here is that we all talk about technology here, but what I learned is that sometimes you don't need fancy technology to innovate. This is an example that for our parks, tree watering, is using very old, we say, GPS technology. And as simple as we put a water flow sensor there, and GPS, we're actually able to track these water trucks, which trees or areas that they water, and how much water they put into each trees. It's very simple, but just basically say, you need to think it out of the box and implement it, right? So this solution has been in place for years and helped the business unit to understand and track what areas, like has the trees been watered, how much trees, and also actually automatically shut down the water once they see, I believe this case, like each tree, 60 liters is shut down automatically, right? Last, I want to mention the people first principle was is that, for example, we open our LoRaWAN network to the local communities, startup companies, and researchers. This is the LoRaWAN gateway that we're putting on top of the U of C building, the Earth Science building. So the entire U of C campus right now, they can use our city LoRaWAN to pilot and try out their IoT devices. And last but not least, I think a few days ago, we had our first City of Calgary AI hackathon here. And the theme is called Blaze the Trail. As thanks to our communication team, it's really great names to innovate the culture. So there are 3 themes, and at the end, we have about 76 ideas submitted through 2 months. Lots of creative ideas. And our plans also, we're going to follow up with these ideas and how we can see how we can help them and bring them into realities. And I want to highlight last week here, these 5 teams compete at at the same spot here. And these are the 5 ideas I want to talk a little bit about that. The first one is the one that actually win the hackathon, is using AI to enhance 311 call. From through one call, the voice call, understand right away that what the customer citizen want, and then provide answer right away before they reach out to even a human agent has to pick up and find the information. The second one is a mobile app that basically able to take a picture of the waste, residential waste, and then telling you that which garbage bin you need to get in, right? So when I demonstrate here last week, it was actually pretty useful. It's like, I should get one of those for myself. Lots of times I'm confused, it's like, which one goes to which, right? And I just make a fun that this is, I should call that project is garbage in, garbage out, right? No, it's garbage in, treasure out. That's actually a really good apps. The third one is AI chatbot for recreation program. That's for live and play. So remember that when we had to book summer camps, book some of the swimming class, now what they're looking at is an AI chatbot able to provide citizen services, right? And there's also another creative ideas about using AI to help citizens find the missing or lost pets. So instead of identify human face, identify your pet's face, dog's face, cat's face, and then do a match. So that's a very interesting idea as well. And the last one is also the tree watering route or geospatial optimization, right? So I say, not these five, I actually say there is other tons of other great ideas that we should help and implement. So I think that's the end of my presentation. I would say, I want to say, let's connect and discuss, and then use AI. AI basically say, let's synchronize our neural networks and exchange our thoughts, right, in AI language. So thank you very much. I hope that, yeah, thanks. 5 minutes. I don't know how much time we have for.
We can get 5 minutes for questions.
Sure, yeah, and I'm here anyway, so. Yeah. Right. Sure, any questions?
Some of these ideas, I've seen other cities, like I think the city of New York does the road mapping to check all the potholes and stuff. So
Yeah.
how often are you connecting with other municipalities on stuff like this? Is there like a symposium, or how do you kind of compare this together?
Yeah, I think that's a really good question. I think I would say we connect very closely with Canadian municipality a lot more than the US ones. And because of the, I would say likely because of our advance in lots of our use cases and adoptions, we got contact by many municipalities and federal and provincial governments. So we have lots of regular talkings with these our partners. So yeah, it's really great that we always compare. And what we're trying to do is, especially on the AI side, to identify some of the common problems. Because lots of these use cases here, it's not just Calgary, right? Everywhere is almost the same problems. So what we've been talking to them is say, compare notes and saying, hey, how does your model work? How does your solution work? And should we just basically make it open source to the point, right? Across these municipalities. And that's something that we have been talking to City of Vancouver, City of Surrey, and to understand that, for example, some of the problems on the water basins, where I say, how does your model work? What kind of data you collect to make it work better, right? So yeah, we have lots of those discussions going on. Yeah.
How do you ensure network security with onboarding all these IoT devices onto your environment? Like if they're, what's the supply chain look like for that? Do you vet it before connecting?
That's a really good question about the security of it. Yeah, I'm glad that, Colin, do you want to take that one?
Yeah, well, I mean, the first part is experiment, right? And you got to go through a step process, partners with your cybersecurity. And you also have to create an ecosystem of innovation.
Oh, it's near microphone, sorry.
Sorry. And then work on an ecosystem of innovation, which means that if there's deficiencies in what you've analyzed from a cybersecurity perspective, then you get the businesses that are building that ecosystem. So as an example, LoRaWAN isn't one company. It's an open ecosystem. So there's a software vendor that does the management of these devices, right? And that includes gateways and sensors. So there's a specification. Does this device conform to that specification? So as an example, the RF is AAES encryption, right? So that's fairly good standard for the radio path. But then you got to look at, well, how does that gateway now communicate with that software? And so there's existing standards. And we just have to have the discipline when we want to move to production to build those factors into securing that service down. But our confidence is very high. And it's always a continuous improvement process, which is part of our work with our cybersecurity partners.
Yeah, and if I could add, basically that's where the team here spent lots of efforts. So went through sort of the vet process, you say that typically you say, yeah, what kind of sensors could we use for, let's say, for a waste stack? There's probably 10, 20 of those. And that's where our vetting process come in here, so all through sort of a certification, understand, is it feasible to use? Secondly, how secure is it? Does it fit into our network? Could it manage by our LoRa network servers, etc. Right? So yes, definitely those practices been going on. Yeah.
When we did a couple of experiments like the smart garbage, our first version of that POC, people stole the sensors right off. They ripped them right off the garbage. So yeah, like it comes in all assets. So as we early adopt, we learn and we deploy. And so like with the TIC lab, we get to do more early adoption before we even consider implementing, operationally at the city. So.
Thank you. I hope that answers your question.
And how do you choose the projects you're going to explore? How do you choose the technologies and the applications to experiment?
Yeah, that's a really good question, and that's part of basically when it's the emergent technologies and how the intake process, we do have a matrix to understand, but it's based on different technology as well, although there's common factor. So for example, like we're looking at, say, what kind of AI project we're going to take. The intake process is looking at, say, feasibility to understand, do you have data? Basically, we have a list of, say, simple questions to our user, understand, okay, what kind of benefit, why do you want to do this? And have you tried any other things? Because lots of times right now, as people say, use AI, AI is the magic bullets, right? And it turns out, oh, yeah, it's probably a Power BI things. So we say, why do you use it? Have you considered other options? And secondly, what data do you have? Are they accessible? And who owns it? Can we access it? And is there any privacy concerns, security concern about your data? And then fourth, basically, we understand that has any other cities done this? Back to your question. And we're going to check, right? Say, if they have done this, why do we reinvent the wheel, right? So there's a matrix, and then after that, if this becomes, let's say, feasible, then another set of basic evaluation come in and say, how much efforts are we going to do with this one? This is like 3 months or 3 years of efforts, right? And how many integration? Because AI cannot just stay alone. So basically, there's a lot of integrations which make it more difficult. So there's complexity as well. So yes, we do have sort of a matrix trying measures. The maturity of these intakes matrix are a little bit different. For IoT, also similar, but for AI, that's what I'm talking about, right? I hope that answered your question, Jason. Yes, I sent you a, should I say spreadsheets? No. Yes, we do, yeah. All right. Good. Good time. Thanks so much. All right.